So this question is from October-November 2019, variant 11, question 21. It says a transverse wave on a rope has a wavelength of lambda and time period is t. The graph shows the variation of the displacement of the particles of the rope with distance in the direction of the travel of the wave at time 0. So basically this diagram, or this you can say graph, is showing us a displacement against time. And the direction in which the wave is traveling is towards right, and we can say that, for example, we can make this, we can trace basically this wave and move it slightly towards right. Just give me a minute, like this. Yeah. So basically, just trying to show you how this wave will move towards right. So after a few seconds, the wave will be at this position. Just assume that. So here it says a particle X is labeled. Yeah, we can see that a particle X is already, labeled over here. See the original wave, black wave. The X point is already labeled. And they're saying that which graph shows the variation of displacement of particle X with time t. So basically they are asking us to figure out the graph of particle X in which the displacement is against time, not distance. Got it? So what we are given in this question is that particle X is at displacement 0. Which means that X is at equilibrium position. So basically equilibrium means that displacement is 0. And we can see that after a few seconds, when the wave will travel towards right, the particle X will move down. You can see that. It will move downwards. Since we all know that particles on a wave can move up and down only. They can't move towards right or left. They just move up and down. So after a few seconds, the particle X will move downwards. So it means that in displacement against time graph, this particle X should move downwards from displacement 0. So you can see that in option A and D, your particle is moving upwards. So straightforwardly we can just eliminate these two options, because we know that your particle is moving down from displacement 0. So just focus on the direction it's moving downwards. So over here we can see that in A and D option, it is moving upwards, in upwards direction. You can see that it's moving in upwards direction, and same goes here. So we just eliminate option A and D. Next point is that it was initially at equilibrium position, which means that the displacement was 0. So so from option B and C, we can see that in B option, the particle was not at displacement 0 initially. So it means that we can eliminate this option as well and select C, because it is initially at displacement 0 and moving downwards. So I hope you get this question, that how we solve it, and we get the answer C.